This is part 12 of the Craftsman 150 drill press rebuild series. If you haven't seen part 11, click the link at the top of the screen. In this video, we're going to be cleaning up the badges and reinstalling them on the drill press, reassembling the motor, and test running it. Hello everyone, I'm Jeff, and welcome to my shop. We've got a lot to cover, so let's get to it. First, I want to say thank you to my friend Matt Blast on Garage Journal Forum, who reproduced the motor plate for me. He's reproduced lots of plates for me in the past, and he does a great job. So Matt Blast on Garage Journal Forum. And as you can see, the reproduction is outstanding. Okay, so the first plate we're going to clean is going to be the model number plate that goes on the base, and I'm using the Meguiar's cleaner wax, which is the only thing I normally use, but this plate is pitted a little, so I'm going to have to use a wire brush. It's pitted right on the model number, so there's no black ink there, so utilizing the brass wire brush is going to not really be an issue, as long as I keep it within that model number area. So I coated it again with the cleaner wax, and I'm going to set it aside. Now I'm going to work on the headband. The instructions for the cleaner wax are you should apply it and then let it dry to a film and then come back and buff it off. So that's where we are now. We're buffing this off of the data plate. And the model number area still looks a little dull, I guess is the easiest way to explain it. So I'm using some of the Mother's Mag and aluminum polish. I'm applying it with a Q-tip, and then I'm going to use a cotton buffer wheel and just buff that model number area. And then we come back with a final buffing, and that plate is done. And then same on the headband, final buffing, and the head plate will be done. Head panel. They don't look brand new, but they look really good, so we're good to hook. Moving on, we're ready to attach those suckers. So you're going to need some of these panel screws for the base. You need a size number 4, and these are a 1/4 inch long. You can get them from McMaster Car. They're called panel screws or drive screws, and I'm just going to get them started by hand, and then we're going to tap them in with that brass punch and brass tip hammer. Perfect. All right, the headbands uses a different size, a number 6, and they're also a 1/4 inch in length. You can even get brass ones, which would probably, look better with the color scheme I chose, but the originals were steel or aluminum, so that's what I'm using, aluminum ones. And just getting it started on one side, and I'm not gonna hit that all the way in yet. I'm gonna leave it loose. And then we'll line up this one, do the same thing, and we're not going to drive it all the way in yet. We're just going to get it started so it holds the band in place. And then we're going to press the band into, mostly it's that top area right across the Craftsman logo, the crown area, getting it to fit in there, and then press down on the sides, and then we'll drive those all the way in. And because it's in a recess, I have to use a punch. I could have used a smaller head hammer, I guess, but I just used the punch. Same thing on this side. Go ahead and drive it in. and then use the punch if needed. Trying to keep it in view of the camera. And there we go. So both those panels have been mounted. And it's time to put the data plate on the stator band that we made. So I measured where the old one goes. And I'm just going to put some tape on the one we fabricated. And then I'm going to mark where I need to drill. I'm going to drill the two holes that are closest to the camera, the bottom holes. So I'm lining up those holes there, and I'm just going to mark them. And then we'll go over to the drill press and drill them. So we're not going to drill all four of them. We're just going to drill the first two. And once we're done, we're going to deburr those holes. We can go ahead and pull the tape off. The aluminum really doesn't require a whole lot of deburring, but the steel does. So next, I take the data plate over to my vise, and I've just got a piece of leather, and I'm using a piece of steel or iron stock that I'm putting a slight bow on the panel itself. The leather is going to keep it from getting marred up, and we're just kind of rounding it over a little bit. Doesn't have to be super bent, but it needs to be bent somewhat, because if it stays flat, then the holes aren't going to line up when we bend the band around the stator. And roughly about that much. So now we're using an eyelet, and I'm just going to press the eyelet in, and we're going to go ahead and fasten both of the bottom ends of the data plate to the stator band. You can use rivets. I've used rivets in the past, just pop rivets, but I have an eyelet, press, so the eyelets look better, I think. So now that we've got that done, we can then bend the band a little bit, and that's what I'm using that block of wood for, and drill out those other two holes, and then press the eyelets in them. And that's enough of a bend so that the stator band will look like it won't have a big flat area when you press it around the stator. And once we're done, we'll be ready to move on to assembling the motor. So these are just some aluminum satin. They look kind of stainless eyelets, and they work great. You can get them at any of your hobby shops, Michael's or Joann's or whatever. So yeah, that looks kind of OEM to me. All right, so here we are with the other end frame, and we're going to install the air cone. So it goes that direction. And once we've got it screwed in, we're ready to install the terminal bar inside the terminal end frame. And then once we get that installed, we'll just set that aside. And here we are with the base of the motor. And I'm going to use a single pole, single throw switch. And these switches, you can get them even at Home Depot, and they look almost exactly like the original OEM Craftsman on-off switches that you find on a lot of these motors. So this motor didn't have a switch. It had an inline switch in the crappy power cord that came with it. So this is where I normally put the on-off switch on all the motors I rebuilt. So now we're going to strip some of the shielding off of the power cord itself. We're going to make sure we've got enough to wire to the switch. And I'm just using a box cutter. And once we score it, then we should be able to pull the wiring out of the sheathing. And then let me reach right across the camera here and grab a pair of dikes, and then we'll just cut that plastic away. So I'm installing a grommet on this opening that the power cord is going to go through. And you'll notice that this end is kind of rounded over where that hole is, and the end where the switch is, it's kind of stepped. So now we're going to just go ahead and attach the first bolt that holds the base to the stator. And it's under the switch now, so you're going to have to use a wrench to get to it as opposed to a socket. And then we can install the power cord in the grommet. And then I'm going to push it on through probably about 4 or 5 inches so that we have room to install the power cord stress relief. Now the OEM stress reliefs were these, I think they're called dog hooks, something like that. They're like a metal C shape that you push onto the cord, and then you use that tool I've got in my hand to crimp it down on top of the cord. And that prevents the cord from being pulled back through the grommet. Nowadays, there isn't a whole lot of stuff that uses these, but you can still get these. I got the hooks and the tool off of Amazon. So now we're ready to go ahead and ground the motor. So I've taken the grounding wire, stripped a little bit off of there. We're going to install a loop terminal. And then we'll crimp it on there. And that loop is just the right size for our bolt that goes through the base and into the stator. So that bolt has a lock washer on there as well, but I'm going to pull the lock washer off and put it on the other side of the terminal. And then we'll just install it. So next I'm measuring the black power cord coming from the power wire to the switch. And we're going to install a blade terminal, the female end on this end. And then another blade terminal on that loose wire that we had. And both of those blades will go to the switch. So then we've got the white power wire, and it's going to get a, I think it's called a bar terminal. You could use blade terminals, it really doesn't matter. I just chose to go with a different style of terminal so that I know which wire is going to the switch and which isn't. But that's the female end, and then the male end will go on that loose white wire that we had. And the other end of those two loose wires are going to go to the terminal bar. So that's the male end. And then we'll go ahead and connect it to the white power wire. And then we'll run it between the base and the stator. And all of this allows us to disassemble the motor, replace the power cord or the switch without having to cut wires and solder and all that kind of junk. So now we're going to install the switch assembly inside the terminal end. So that is the switch shield, and that is the switch insulator. And I'm just comparing it to a diagram of the 115 6968 motor, I think it is. And then the switch itself. And then we'll just screw all that in there. And here we are attaching the lead wires out of the stator and base onto the terminal bar, and then attaching the ones that go on the top of the terminal bar, and then soldering in the capacitor. So I got a little bit out of sequence here, and you really don't need to solder the capacitor in at this point because we have not installed the stator band yet, and it helps if the capacitor is not in there, but we'll get to that and you'll see what I'm talking about. Since this does not have the original capacitor in here, I kind of flattened out that capacitor shield, and because it was really bowed to fit around that round capacitor, but I'm using spacers and longer machine screws to attach this on there now, which means the motor's not going to sit flush, but I've got a plan for that. So once we get that shield on there, we're ready to install the rotor. So we're installing it with the switch facing down because the terminal end is already on, and this is the other end, and we have not put any bearings or anything on it. So once we get it on there, we're just lining it up as best as possible, and then we're going to go ahead and put the through rods in there. And we're going to hand tight the nuts on those through rods. So that it holds the motor together, but the end frames are not on there super tight. So now we're ready to do the stator band. So all you got to do is just start the stator band on one end and make sure it's threading into the base. And once you get it going, it should work its way in there no problem. And then we'll wrap it around. And then we're going to flip the motor upside down. And this is what I was talking about. I had to go back and I removed the capacitor so that you could see what was going on, but bending this in there now. Like I said, I normally use aluminum for this instead of steel, but I gotta say I like how the steel has turned out. And go ahead and make sure you snug it up to the base as best as possible on the far end, and then just bend those pieces at like a 90-degree angle, and that'll hold that end in place. And then you can use a pair of pliers for the other legs and pull it taut. But the steel seems to work much better than the aluminum. The aluminum, when you get to the bend over portion that I'm going to show you in a minute here, I've had it break on me before. And this steel is a lot more forgiving in my opinion. I'm looking for a pair of pliers. There they are. Pull that taut. So you could do a much tighter job of the band than what I'm going to do, but I want to have enough room to really work it around those end bells if I need to remove an end bell or an end frame and then be able to get it back under the stator band. So all we're going to do here is we're going to take one leg and we're going to bring it to about the halfway position and then bend it over. And then we're going to bring the other one and bend it over on top of that. And then we're going to use a pair of needle nose pliers and we're going to bend about half that distance. And if you wanted it really tight, you could bend it an additional time, but this is enough in my opinion. You can tap it down with a hammer and a punch, and we're going to do the same for the other side. And then we would resolder the capacitor and reinstall the capacitor shield on the bottom. Next, we go ahead and tighten down the through bolts, and then we're going to be installing the bearings. So these bearings have an extended race, and that extended part needs to face to the inside of the motor. I've already got the shims on the rotor right now, so we're just ready to tap this bearing on. Now remember, the rotor is loose inside the motor right now, so I'm holding the opposite end with my hand and I'm just tapping the bearing on there. I used a washer so that it's distributing the pressure over the races of the bearing. And once I've got that bearing seated on the rotor shaft and it's all good to go, then we can line it up with the opening in the end frame and install it there. So now we need to take the motor and turn it so that that bearing end is facing up. And then we're going to put on the spring washers. There was 2 of them, and they're usually stacked. So then we're going to put on the gasket and line up the holes for it. And then the end cap. And then the felt. And then the felt cover or felt cap. And these felt caps, they say, you know, new departure bearings inside or something to that effect. So I've aligned them up so that they're facing properly. And we'll screw everything down and then we're on the terminal end. So if you haven't already, go ahead and install the terminal cover. And then I just slid on the 3 shims and there's the bearing with the extended race facing into the motor. I've lined it up with the bore and then I'm just going to tap it on there. And once it's on there good, get my washer off of there. Then we're ready to put on the gasket. This side typically does not have a spring washer. And then the end cap. We're just lining up the holes. And then the bearing felt. And then the bearing felt cover or cap, and making sure the words are lined up with the bottom of the motor. And then we'll just screw it down as well. So when I screw these parts together down on each end of the motor, you do it kind of like you would tighten lug nuts on a tire. You know, you kind of work in a cross pattern. So I'm just hand tightening the screws now, but then I'll tighten one and then go to the one across from it, and then the next one, and then across from it, rather than working in a circle. And that kind of centers that cap and everything. It probably really doesn't matter, but that's how I do it. So now we're ready to test the motor. Like I said, it's not going to sit flat because of that cover on the bottom, because of the capacitor that's being used, but not a problem. So we'll make sure it's turned off. Yep, and then we plug it in. And then we make sure that we're not going to electrocute ourselves. All right, we're good. Switch it on, and it's running like a champ. So we'll turn it off, and we'll listen to hear that click. Make sure it's not smoking. And as long as we hear the click, when it spins down, we know that the centrifugal switch is operating. So that is the motor, and it is running like a champ. I hope you enjoyed this. If you did, please like and subscribe. Next up, we'll be assembling that drill press. So more to come. Thanks for the interest, and I will see you next time.